Hello, everybody. Happy Thanksgiving. These notes are on natural language processing. And last time we talked about the idea of different levels of grammars, the Chomsky hierarchy. Today I want to talk about a particular one of that hierarchy, the one that is most used in natural language analysis. This section's based on an item on the web, which itself is based on a chapter of a book on computational linguistics. Now, context-free grammars are what we're going to talk about. As I mentioned in notes 14, the regular grammars are not powerful enough to generate natural languages. We need at least a context-free grammar to generate these languages. There is some opinion that even that isn't powerful enough for a natural language, but it does many more things than we could do with the regular grammars we have. Now, I'm going to show an example of a small part of such a grammar, and then I'm going to try to use it in two different ways to parse a sentence. The first part will be relatively easy, and that's the part I will probably give you a homework on. The other one is difficult, and I'm just going through it to give you a feeling of how this really works. So here's the idea. We begin by defining the terminals as the words in our language. So basically, we will have a dictionary with all the words that we are playing with in English. Now, this particular example is a rather small number of words. It's made for a language involving airplane flights. So most of its words have to do with that. Now, the sentences of English are strings of these words. To be grammatically correct, in other words, to be accepted into our language, they must obey the grammar rules. And I'm only going to look at some of them. There are grammar rules I'm not even going to touch upon here. The first thing we do is introduce the parts of speech, such as noun and verb, into our non-terminal set. There are eight traditionally, if I remember correctly: noun, verb, pronoun, adverb, adjective, conjunction, preposition, and interjection. We're not going to be worried about interjection, and we're not going to be worried about conjunction. Those would be a little more complicated. They'd make bigger sentences for us, and we're going to have enough with what we're doing. Now, this particular language adds another group called DET, which stands for determinant or determiner. There are three in the English language: and the. This and that, they might be involved, but we won't use them if they are. The convention I'm using here is that the non-terminals are going to be in italic and the terminals are not. I may slip on this a few times, but that's what I'm going to try to do. So here's the first set of rules in our grammar. Basically, all this is doing is defining our language. As you can see, we have, well, they do have this and these and that, but I didn't use them. And I added one to theirs. I added nonstop, I think, among the adjectives. And I'm not going to use all the words, but they're there if we wanted to make sentences with them. Now, that's not enough. What we need to do is decide what a sentence is in our English. There are many different forms of sentences in English. We can have an interrogative sentence, which asks a question. We could have a subjunctive sentence where we could have an inverted sentence where the verb comes before the noun. We're not going to look at that. To make life simpler, we're going to give one sentence structure. And it's going to be a simple one. Well, reasonably simple. Now, as you remember, every grammar has to have a starter symbol. Our starter symbol will be the traditional S. And in this, S stands for sentence. And I think I have that a little wrong. I'm sorry. I modified it later to make that PP. Now, or NP, VP. There's lots of possibilities here. I put the PP in because I couldn't get what I wanted any other way. So we'll see how this works. Now, NP has lots of possibilities. I added quite a few of these to the original. The author of this particular book wanted to make a big deal between the difference between proper nouns and nouns, primarily because proper nouns can't take the determiner before them. So that makes a lot of duplication that we wouldn't need if we just said a proper noun is a noun and not worried about it, and figured out the problems with the determiners by looking at other things. So we've got ourselves, I see what I did, pardon me. No, it's okay. I don't think it's going to cause any problem. I think we're okay the way we are. I have to be careful because I played around with this too much. Now, I'm going to give you a sentence. I'm going to show you how we will guarantee that it is part of what we have. I'm going to get rid of this for now. We'll see. I'm going to say that S goes to NP and VP. That's what I have here. NP, one possibility is it goes to a pronoun. For VP, a possibility is a verb and an NP. So I'm going to have NP go to determiner, adjective, nominal. Nominal is going to go to noun, preposition, part. That's going to go to the next part, and so on, until eventually we get down to a correct parsing of the sentence. I need a nonstop flight from Baltimore to windy Chicago. This is the easy part. You just look up here, look at what's there, and try to trace it down piece by piece. That's the way, a reasonable way to do it. Now, there's a harder way to do it. And this part isn't something we could write a computer program to do that easily. If you remember, we said that each of the languages has a machine model that goes along with it. The languages with regular grammars describe the recursively numerable languages. That's not all of them, but it's a reasonable, it's a big subset, or it's a subset. We need a machine model for the context-free languages. The machine is called a push-down automata. Now, I've sort of done a push-down automata, but the way a lot of people do this is they model it as an augmented transition network. So that's the way I'm going to go at it here. First of all, you've got to remember that the augmented transition network is incredibly recursive. I'll show you why from up here. S goes to noun part and verb part. Verb part goes to noun part. noun part can go to PP. We got a PP here. We got one here. They're all over the place. You'd have to write a lot of recursion for this. So it's a little bit different from the automaton we've been looking at. First of all, you'll notice it's a network. It's a group of automatons. Each one of the automatons has basically the chore of doing one of these sets of rules. There's an automaton for S, an automaton for NP, an automaton for nominal. I do honestly think that I did put this here. Let me put it back just to make sure. You'll see why in a minute. Now, there's a little strange thing here. In all the automata that we looked at, we have a state of the automata and we have a token, something that comes in, part of the output. And those two together determine what the next state is. Well, in these automata, this network, there's a sort of a wildcard. It says that in certain nodes, you can jump out of that part of the automaton back to where you were. It's basically a subprogram, a function. And it says you go into the ones by going to a different automata, and at some point, you get out of it. And when you get out of it, you say to the item above you, I found what you wanted. We'll see that in a minute. So the jump is going to be a little bit different than you're used to. Now, the push-down automata, I said, is a push-down automata. Well, that probably push should remind you of stack. So this automata has a stack connected with it. I've only touched the surface of what can go into the stack. The stack is used to take care of things like agreement of the noun and the verb. The fact that the and a plural number are and a plural number aren't allowed together. All kinds of the little grammar rules that you learned way back when and probably forgot. All of us forget them. Now, there's what a simple one looks like. I don't have the PP in this one, so I guess I did drop the PP. I thought I didn't, but it looks like I did. So I can go back here and not put that in. So what this says is, you're going to start in the state S. To get to the state S2, you need to pass a noun part. And to get from S2 to S3, you need to pass a verb part. And to get out of the network, you need a jump. So this is different. These aren't tokens of the word. These aren't words of the language. These are non-terminals. What does it mean to say that a non-terminal is the input? Because the input is not a non-terminal. The input are the words of the language. But what that means is, if you want to get from S to S2, you suspend what this network is, and you go to the network that begins with NP, and you work in that network. And at some point in that network, you jump out of it and say, I have an NP for you. And you go back to this network. We're in S, we get an NP, we jump to S2, or we go to S2. Now, N is a lot more complicated than S was. This says, for example, that we can have an NP that's just a pronoun. We can have an NP that's a noun and a pronoun and jumps. We can have an NP that's a determinant, an adjective, and proper noun. We can have a determinant and a nominal. We can have an adjective and a noun and a nominal. Whenever you see jump, what that basically means is I found an NP. One of the rules works here. Now, you got to be careful with this because sometimes there might be two ways you could go. But you might have to look ahead at words coming up to get an idea of what you want. So they're a little more complicated than the simple ones we saw earlier. Now, when we move from one state to another, what we're going to do is we're going to pop the stack and put a new state on it. The stack is going to have the list of all the states that we have gone to and then gone to another automata, then another automata, and then another automata. And we have to basically empty out the stack if we're going to finish. We have to get the stack down to nothing. We're going to assume that when we jump, we return a token of the name of the automaton. So if we're looking for an NP, we're in the NP automata. When we jump, we return NP, and it's a token, and it goes in front of the other tokens. Now, I will try to parse that sentence up above. I need a nonstop flight from Baltimore to windy Chicago. I want to make it easier, so I'm going to presume that I've already split it into the parts of speech. And so I don't have to show you that we're going to get those. So my tokens will be the parts of speech, plus the NPs and SPs and S's and all that. This is a very long ATN, and you'll see why I don't think I want to give you a homework on it. So let's start off here. Oh, these are the rest of the networks. There's the S again. There's nominal, there's verb part, and there's preposition part. And I already had noun part up above. I just couldn't bear the thought of having to copy it down here again. You can see it up above. As we go through this, I'm going to look at two items, the stack and the next token. The stack's going to contain states, and the token will be non-terminals, so the parts of speech or sentence parts. And as I said, we're assuming that we took all the words and turned them into parts of speech. Each part of the network is an automaton all on its own. And we're going to start with the S one. I've talked about that before. So let's look at what we do. I begin by pushing S onto the stack. My first token is a pronoun. Now, if I look at S, the only way I can make progress is to have an NP. Because if I'm in S, I've got to get an NP. So I suspend what I'm doing with S, and I go over to the NP network at NP. Over here, I keep track that I still have S as an unfinished chore. And I have NP, and I have to try to find an NP. I have to parse what I have to get myself an NP. So I have a pronoun. Well, it turns out, if you look at the NP back here, if you have a pronoun, it can take you to NP7. So I'm saying that this pronoun took me to NP7. I'm sorry. I didn't have that right. And if I jump to NP7, then that's the new state. I get rid of the state NP and I put in the state NP7. Now I see a verb. Well, I don't have any place to go in NP with a verb. And if you look at NP7, the only possibility in NP7 is to jump. So I'm going to do a jump. I'm going to get out of the NPs. When I get out of the NPs, I return a token NP. And we pop off the NP. Oh, down here, pardon me. We pop off NP7. We go to state S. And in front of the verb, we put NP as a token. Now that's very convenient because S with the token NP takes me to S2. So I'm making progress. I'm moving through. So the S is now S2. I see a verb. Well, the only thing that can get me out of S2 is a verb part. So I have to go to the verb part portion. And the first thing in the verb part portion is a verb. It takes me to VP2. And I keep saying over here, this consumes, this eats up. What it means is it goes away. So I've already done the pronoun. I've already done the verb. I'm at VP2. Well, if you go back and look at VP2, oops, something's wrong. I forgot the determiner there. No, I have NP. So NP is what I'd like to get. So how do I get NP? Well, I'm at VP2. I see a determiner. Determiner's not there, but an NP is. So we'll try to get an NP. So what can we do? Well, if we go with NP and we look at determiner, it jumps us to another state. Adjective jumps us to another state. Nominal takes the noun away from us. Then we see a preposition. That takes us to another state. Now, we have not eaten up the preposition. We've eaten up only the one up above. We took the noun. We still have the preposition. In state nominal 2, a preposition is enough to jump back. So we jump back, and now we're in MP3, and the token we sent back was nom. And MP3 with a nom, let's see, MP3 with a nom takes me to NP5. So now I'm at NP5. And NP5 with a preposition says, well, there's no preposition coming out of NP5. So what I'm going to have to do is say, I need a VP2. I need the NP. I'm finished with the NP. So now I go to VP2 and return NP. And this takes me to my next state. Now I'm not going to do the rest of this. This runs on for pages. And I've been fooling around with it for a few days. I'm not guaranteeing there isn't a mistake somewhere in there. But it should give you the flavor of what we're doing. You can see that there's a lot here to parsing a language. Now, I haven't even begun to talk about the more, I won't call them esoteric, the more hidden rules of grammar. For example, if you have a I, you use I am. But if you have he, you use he is. He is third person, and is a third person verb. I is first person, and am is a first person verb. These have to agree. So there would be in the stack there'd be an additional requirement on the arc. It'd say the uh,